Okay, chapter 5, lesson 1. Chapter 5 starts a new unit on geometry, and that's going to actually be the next few chapters. We'll deal with the geometry form or the geometry portion of the math that we're going to deal with this year. So, lesson 1 starts to talk about lines and parallel lines and perpendicular lines. So, let's just get right into that here. Come on. All right, so the first thing I want you to know is that there are symbols for parallel and perpendicular lines. So before we get much further, I'm just going to say that this is a note-intensive lesson. So I need you to write down symbols. I need you to write down definitions. There's actually a lot of definitions in Chapter 5. So I want you to make sure to keep up with those, because if I ask you, what do parallel lines look like, and you look at me and shrug your shoulders, that might be a little bit of a problem. So parallel lines, symbols. Actually, it's just looking like two parallel lines. Just two lines straight up and down, almost looks like an 11. All right. Perpendicular lines, however, this is their symbol. Why would that be their symbol? Because what are perpendicular lines? If parallel lines are lines that never cross, perpendicular lines, okay, would be lines that cross, but they cross to form right angles. And notice in that kind of symbol like that, it actually forms a right angle here and a right angle here. So that is the symbol for a perpendicular line. So again, if we want to define it in our own words, parallel lines, lines that will never cross and they remain the same distance apart. All right? That's with this pen, that's a lot to write in that box, but that's what I want you to know. Parallel lines are the same distance apart and they will never, ever cross. Perpendicular lines are lines that cross, but you need to go further than that. They are lines that cross to form right angles. All right, so perpendicular lines, lines that cross, or intersecting lines that form right angles. So if I were going to draw it, you can draw something like that. They don't always have to be straight up and down. Parallel lines. Perpendicular lines. Most often you will see them looking like this, almost like the X and Y axis. On our coordinate planes. Describe a real-world example of it. So real-world example, parallel lines would be like railroad tracks. All right, those are parallel lines that keep going, and they remain the same distance apart. So if we are talking about perpendicular lines, well, perpendicular lines could actually be found anywhere. Maybe like on the street corner. Like these could be streets, okay? So these are perpendicular lines. You've got a line, a road that goes this way, and a road that goes this way. So like the four-way in town, those are intersecting lines. Okay, so with that being said, let's move on and actually get to the lesson. All right, here's all these yellow words. So all of the vocab words that we need to talk about. Okay, so for today we are talking about a set of parallel lines which are cut or crossed by a transversal. And that's what that line is right there. Let me get my highlighter back. Do that, maybe red. This right here is a transversal because it crosses these two parallel lines that are right here. So these blue or purplish looking ones, those are the parallel lines, and it is cut by a transversal. That transversal can go any direction it wishes. All right, it just has to cross them. So that's what a transversal is called, a line that intersects other lines. So when we talk about interior angles, I am talking about angles that are inside of the parallel lines. So let me get this. These right here, orange, are interior angles because they are inside of the parallel lines. Whenever I talk about exterior angles, if I were to talk about the exterior part of your house, what would that mean? That would mean the part that is outside. So like 1 and 2, 8 and 7, these angles right here, those are exterior angles because they are outside of these parallel lines. They're outside of them. Okay, now goes a little bit further than that. If I talk about alternate interior, so interior, I'm talking about the orange ones, and if I'm talking about alternating ones, I need to talk about ones that are on opposite sides of the transversal. So like this angle right here, 4, 6, because one is on the left, one is on the right, but they're both still inside. If I'm talking about, let me get another color here. I could also say that 3 and 5 are alternate interior. 3 and 5 are alternate interior. They're just on the opposite sides of the transversal, but they are both inside. Okay? Alternate exterior are lines that are on the outside of the parallel lines, but one's on top. Sorry, not one's on top. One's on this outside on the left, one's on the outside on the right. Alternate exterior could also mean 1 and 7. Those are alternate exterior. Okay? Now, here's what I want you to know about the alternate. Well, let me do one more before we do that. Let's talk about corresponding. So corresponding angles, hope it's not getting too confusing with all these colors on here, but I just want to show you how things are related. Corresponding are things that go together, all right? Things that have a relationship. So ones that are in the same position. You see how this number 2 right here is on the top of a parallel line on the right of the transversal? It corresponds to angle 6, which is on the top of a parallel line and on the right-hand side. Those are corresponding. 1 would correspond to 5 because they are both on the left side and on the top of those parallel lines. Different color here. Let's talk about 4 would correspond to 8 and 3 would correspond to 7. So just ones that are in the same position. Now, the reason why we talked about this right here, because alternate interior, alternate exterior, and corresponding angles are equal in measure. All right? So if I told you that angle 1 was 70 degrees, you know, because of alternate exterior, right? This is on the outside of that. Alternate exterior, if I told you that all alternate exterior angles are equal, or alternate exterior pairs anyway, then that would mean that 7 is also 70. All right? So let's say I told you that angle 2 is 110. So this angle right here is 110 degrees. What is the alternate exterior of that? Angle 8. So that would be 110. All right? Let's talk about alternate interior angles. Alternate interior ones on the opposite sides, and those angle pairs are equal. So if I say that this is 70, then you know now that 5 is 70. If I tell you that angle 4 is 110 degrees, then that means angle 6 is 110 degrees. So that's what we're talking about. Those are all equal. Corresponding angles. Check this part out. Number 2, angle 2 corresponds to 6. Are they not both 110 degrees? Yes. Angle 7 corresponds to angle 3. Both are 70 degrees. So it'll just take some practice with that to realize what those relationships are, but you need to know absolutely these 3 right here are probably the most important. Alternate interior, alternate exterior, corresponding angles. Okay? Let's go down and do a little bit of work with these. It says classify each pair of angles in the figure as alternate interior, alternate exterior, or corresponding. So 1 and 7, they're on opposite sides, so they cannot be corresponding. They're on the outside. And when I'm saying outside, I'm talking about all this, maybe. Let's try this. all of this inside of these lines would be considered my interior. So if I am saying alternate exterior, I'm talking about ones that are outside. So those are on opposite sides of this transversal, and they are outside. So 1 and 7 are alternate exterior angles. 2 and 6. 2 and 6. One is on the outside, one is on the inside of those parallel lines. Notice they are in the same spot. So those are called corresponding. Those are corresponding angles. All right. I want you to pause it and try A, classify angle 4 and 6 as what type of angle. All right, back with me. 4 and 6, they are on opposite sides, so they cannot be corresponding. Opposite sides, angle 4, angle 6, they are inside, so they are alternate interior angles. Alternate interior angles. All right, find missing angle measures is the next part. Find missing angle measures. So when two parallel lines are cut by a transversal, special angle relationships exist, which we've talked about. If you know the measure of one of those angles, you can find the measure of all of the angles. So suppose you know that measure of angle 1 is 50. The measure of angle 1 is 50. So if this is 50, there are some other things you need to know, all right? So first of all, alternate exterior will tell you that angle 7 is 50. Now, with that, there are some other things that we need to know. So those two right off the bat. Angle 1 and angle 2 form this straight line right here, okay? So if this much is 50 of it, how much do you still have left until you get to a straight line? Every straight line, add this to your notes, please. Every straight line has 180 degrees in it. Those are called supplementary angles. Supplementary angles add up to 180. So angle 1 and angle 2, supplementary. So if angle 1 is 50, that means angle 2 is 130. Now, alternate exterior, I know that angle 8 is 130 because it is an alternate exterior angle to number 2. 2 and 8 have that pair. Okay? 1 and 4 make this straight line right here. All right, there's another straight line that goes through there. And if angle 1 again makes part of it, then that means the rest of it is angle 4. So if angle 1 is 50, what does that leave for angle 4? 130. So if angle 4 is 130, then by alternate interior angles, angle 6 is 130. 6 and 5 are supplementary. They make this straight line right here. So if that's 130, angle 5 is 50. And alternate interior angles will tell you that angle 3 is 50. So lots of things. They give you one number, but you would be able to figure out all of those. Every single one. All right, example. A furniture designer built a bookcase. Line A is parallel to line B, so they do need to tell you that these things are parallel for you to assume this. You cannot just assume it by any 3 lines that you find. It says angle 2 is 105. Angle 2 is 105. Find the measure, that's what that means, the measure of angle 6. Find the measure of angle 6 and the measure of angle 3. So, measure of angle 6, angle 2 and angle 6 form that straight line right there, right? That's part of it. Angle 6 will give you the rest of it. So if I know that there are 180 degrees in a straight line, I should be able to take 180 minus 105 and get 75. So you are going to tell me that angle 6 equals 75 degrees. Now, if angle 6 is 75, then you automatically know that angle 3 is 75 because those are alternate interior angles. It doesn't look right. Angle, come on. Angle 3, 75 degrees. Okay, So with that, pause it and try B, please. All right. It says refer to the situation above. Find the measure of angle 4. Measure of angle 4. Well, if I know that this is 75, I could subtract here and get 180 minus 75 and get that this is 105. Or there's another option for you. I know that, let me erase this off of here. Angle 2 and angle 4 are corresponding because they're in the same position. They're on the left of the transversal underneath the parallel lines. So if angle 2 is 105, then angle 4 is 105. Either way, you would get 105, just your reasoning may be different. One would be corresponding and one would be that it's supplementary to angle 3. Either way you want to work it is fine with me. All right, let's move on. Now, I'm hoping that I've kind of unlocked the key to a lesson that's longer than 15 minutes. So we're right now on 16 minutes. I'm hoping, fingers crossed, otherwise I'll have to re-record. So, last example. In the figure, line M is parallel to line N, and line Q is perpendicular to line P. The measure of angle 1 is 40. Measure of angle 1 is 40. Put that in there. What is the measure of angle 7? What is the measure of angle 7? So, here's what I know. If angle 1 is 40, that means also angle 3 is 40, right? Because those are corresponding. So I could say that all three of these angles right here, angle 3 plus angle 8 plus angle 7, those all form that straight line right there. Now, we know that angle 8 by this box right there is 90. So if I know that angle 3 is 40, angle 8 is 90 degrees, I should be able to figure out what that is because I know they all add up to 180. So 40 plus 90 is 130, so that means x would have to be 50. X would have to be 50 degrees. Okay, there are other ways to do that too, but that is one, probably the shortest way I can give you for that. Okay, so with that, try those. Make sure you refer to those notes often. If you have any questions, let me know. Good luck.